tNavigator presented by Ellis Ortiz. Ellis will cover tNavigator's seismic capabilities, including analysing seismic data, seismic well tie, data visualisation, and more. If you could just pop to the next slide, please, Ellis. So just a quick run through of some of the details for the webinar. All participants are automatically muted. So if you do have any questions, please just pop them into the chat function and we will run through some questions and answers at the end if we have enough time. All these sessions are recorded and they will be posted to our YouTube channel once they are complete. And I will now pass over to Ellis. Thank you very much.
Good morning, everyone. Thanks for joining this webinar. So today's agenda looks like this. First, I want to walk you through the integrated advantage that tNavigator presents and how easy just to connect all domains within one single platform. Then we're gonna go and check the seismic module and see the core geophysics workflow that we have from seismic interpretation, seismic well tie, attributes, and velocity modeling. We like to call these the core geophysics workflow. So I'm gonna go into detail into that. Then I'm gonna talk and present you about the development velocity, how quick we are to develop not just the seismic module, but tNavigator in general is one of our key differentiators, and it's very, very good. Our clients love this, how quick we develop and implement new features. And finally, we will see the software in action and see practical applications, mainly for geophysics and maybe some integration. So let's just start, and thanks for joining the webinar again. So let's start the webinar with this slide. This is our 20th anniversary. So this is tNavigator's 20-year journey. I think it's important to mention how quick we have grown as a company. This is a very quick and a high-level timeline of our products, our company. We started as a simulation company, or our first, I'm just gonna put a spotlight here. We started in 2005 as a mainly simulator for dynamic models, and then we started to grow and more and more and more, introduce more products. Our clients were loving the results too much that they asked to, okay, we like to also visualize all the results, have a nice GUI. So the model designer was introduced in 2017. Then clients were asking for more. So geologist designer was introduced 2020, network designer, etc. Then finally in 2022, I need to remove the laser for. Sorry, I cannot go to the next slide with this laser on. There you go. I'm sorry. So 2022, our seismic module was introduced as a standalone module. And then what happened? We continue to be a true integrated company through the years. One of the key differences that we have is that our product is under one single source code, which is written in C++ and CUDA, which means that it's optimized for multi-GPUs and CPUs. So our software will run with the most modern hardware available, and it will be optimized, which is very good. It's not using just wrappers around different pieces of code and call it integration. It's really integrated. And finally, we have over 300 commercial clients. So let's take a look. What's the challenge these days, or the main challenge in the subsurface environment for different disciplines? It's always fragmented. It doesn't matter if you're a small IOC or a super major, it's always fragmented. So traditional approach, and it's still valid up to today, multiple software packages for different disciplines, petrophysics, maybe geology, geophysics, core geophysics, very niche geophysics. Then we can continue for reservoir engineering, production engineering. So it's so difficult and so time consuming to just do all this data transfer between not just the software, but between domains. Version control, it's always a nightmare. So all the versions are not compatible, etc. And when you have over 100 or 20 applications, it's just too difficult. We can just get inconsistent rotations, etc. The most important thing, we'll lose a lot of time. And obviously we have unstable wrappers and plugins. It's not real integration, but thankfully tNavigator solution, it's unified. It's just one single platform, single architecture. Everything is synchronized real time, single source of data for all of your disciplines. And the most important thing, it's immediate cross-domain collaboration and updates. So as soon as I update, I don't know, a geophysical interpretation, can be everything can be updated up to my I don't know, dynamic simulation. So easy and streamlined workflows. So now let's take again the true integration. This is about seismic, not integration. However, I wanted to emphasize and highlight how the seismic module doesn't work in isolation. It's part of a fully environment subsurface ecosystem. So we're not talking about a brand or something. We're talking about disciplines. So geophysics, reservoir engineering, geology. We can optimize everything with our uncertainty engine, production engineer. But the most important bit is that the data will be flowing seamlessly between domains, so everyone can just work under one roof and make better decisions and faster. So that's the true power of TNAV, the integration. Now, seismic module. In TNAV, we have something called, or we like to call it, the core geophysics workflow, and it covers seismic interpretation, the classic. We can do and have different tools to do advanced horizon and fault interpretation, and that's basically just building the backbone of the reservoir model. Then seismic well tie, super important. We need to create a synthetic seismogram and have a good and reliable correlation between the seismic data and the well data. And obviously this will enhance our interpretation confidence. Then we can move to seismic attributes, 2D and 3D. This is when we start seeing geology, really extracting geological insights, having better reservoir images, etc. And obviously we can reduce risks, but the most important, we can maximize the value of seismic data. And we also have velocity modeling, obviously just to have an accurate tool to do domain conversion and just kind of bridge the gap between time and depth. And again, everything is integrated and everything flows so easy between these disciplines and obviously the rest of tNavigator. Now, let's take a look at seismic interpretation and well tie. I'm just going to show you some of the features that we have before we go into some real life examples. So how about the interpretation? Yeah, it's not an issue. We can cover and handle 2D and 3D surveys. We have multiple visualization tools to work with this. We do have several auto tracking tools to interpret the seismic data, faults, and horizons. We can obviously give it a touch of manual refinement, fault interpretation, and polygon workflows to extract useful features. We can do geobody extraction directly from seismic, which is extremely useful. And also, the most important bit, everything is in communication with all the modules, not just the geological or the static modeling, all the modules. This is kind of the big difference. That seismic well tie, this is when we generate the synthetic seismogram. Obviously, we can extract wavelets. We can cover from analytical, statistical, and deterministic. They're very good. We can have good time-depth relationship management. We have excellent tools to do this. We have a brand new time-depth relationship manager just to set hierarchies and priorities for time-depth relationships. It's so easy to have different TDRs. And most importantly, we have quantitative tools to assess the quality of the metrics and the well ties. And I'm going to show you this in a moment, but it's kind of like the overview or the capabilities of these two modules. Then we move into seismic attributes and velocity modeling. Attribute analysis, as I mentioned before, we do have a good library of 2D surface attributes, over 50 of those, and you can have a look at them. We have the half energy, average envelope, RMS, etc. There's 50 of them. We also have 3D volume attributes, signal processing, for example. We have 21, and here are just some examples. AGC, the convolution, RMS, a good collection of post-stack processing filters, etc. We also have complex trace attributes. So we take the real part of the signal and the imaginary part of the signal, and we have the classic envelope, cosine of phase, instantaneous frequency, etc. Also, some discontinuity attributes. These are excellent to highlight faults. We have the classic chaos, variance, coherence. We have ADEMAT, which is an algorithm to automatically extract faults. It's very powerful. Then also we have structural attributes, kind of consistent dip, relative acoustic impedance, structural smoothing, etc. And we have colorization attributes as well, like blending attributes, chromatic shift, and a dedicated spectral decomposition attribute. Then velocity modeling, super important as well. We can do a good analysis, seismic velocity analysis. We can take stacking velocities, interval velocities, average velocities. We can convert those as we wish. We can also take well velocity from well data and start adjusting the velocity cubes if we want. We have an option to create a very quick velocity model just with check shot data. We can just basically just take create an average velocity cube. We take the input data at the well location and just we extrapolate horizontally with a radial function. It's super efficient and quick to create a velocity model. We have a more robust approach, which is a layer cake velocity modeling. We can take different velocity input, velocity sources, velocity cubes, just constant values, etc. And finally, one of the most, I think, powerful things, we can start using these different velocity models or perturb a velocity field and input that directly into the uncertainty and sensitivity analysis engine. And it's very, very powerful and fast. And why not? A bonus, we have a new acoustic inversion algorithm, which has been released in the latest release of tNavigator. And we also have a machine learning inversion approach when you have lots of wells, and it's also been proven very, very useful. We have clients that have drilled with the ML inversion algorithm. Now, one of the key differences that we have here in tNavigator, rock flow dynamics, is how quick we implement new features. Let's take a look at this. So, as we speak, we have at least 25 developers in just for the seismic module, not just, so this is huge, just for seismic. So from 25.1 to 25.3, we introduced at least 40 key features for the seismic module, which is a lot, from visualization to algorithms to usability. So it's very important to mention that most of these features are client-driven, and these are shaped by real user needs, not real user needs, not just what we think will be better. And it's important to mention we have 4 releases per year, so we keep updating the software, and the software gets better and better with every new release. I think it's safe to say that the seismic module is the one that is growing the quicker. That's why we have 25 developers and many, many, many features coming. And I'm just going to give you a real example on how it works. I'm going to call it velocity modeling feature. I'm not going to name the feature, but it's a key feature in velocity modeling. And what happens? One of our major clients, we went to visit them to their offices, and we held some workshops, some training, some very good meetings with them. And then they came up with a kind of list of features that were missing for them, for the seismic module. And we prioritized those. And for example, this velocity modeling feature has the highest priority. So we identified this as high priority. And we spoke with them. We had meetings to see the requirements, the technical feasibility, etc. This happened in September 2025. These dates are real, by the way. By October 2025, we had an internal review with developers, product managers, etc. And we said, okay, I think we can have a solution for the client. This is not a trivial feature, and we have meetings going on, but we're confident that this feature will be scheduled in 26.1, which is Q1 next year. And I think this proves and shows that we can develop and be aligned with our clients' needs, and we can be very, very fast. This is non-trivial. This is a real computation. So I think it's quite fast to introduce a very good feature like this one, which I'm not going to mention here, but it's an excellent time frame. Now, so that's kind of a brief introduction on the seismic module, some high level of what can we do. Now I'm going to show you some real examples of the software just to prove all this. So let's do that. So now, yeah, it's working. So now let's take a look here. We have a classic tNav layout. We have a cross-section window at the top left. Bottom left, we have a 2D view or 2D map. On the right-hand side, a bigger window, we have a seismic tab where we can do all the seismic interpretation and displays. And we have a floating widget. This is a new menu called composite line, which has been introduced in 25.3, which is very, very good to work with seismic composite lines. We can edit them, we can just scroll them, we can snap them to inline, cross lines, well data, etc., etc. So I'm just showing you how easy it is to set up a good layout and start visualizing your data, different attributes, of course. We have RMS at the top left, we have chaos at the bottom, and interesting at the right, you'll see we have different attributes together in an interpretation window, and it's so easy to manipulate. Here I'm just moving the composite line. We can do it that with the arrows, just like I'm showing here. We can also take the composite line and move it around, and you can see that the attributes obviously are updated because this is a composite line with different attributes, so it's so easy just to have a view of different attributes, and it's very powerful just to QC or check for lateral continuity when you're interpreting some faults, maybe just to have that. And those yellow lines are intersection lines. So as soon as we click on those intersection lines, we can move to or jump to the cross line or inline. It doesn't matter. It's so easy. And if you want to go back to the previous view, you'll see in a moment. It's so easy. You just go and click on the yellow line, and there you go. You go back to your composite line. It's very easy and interactive. So everything is connected. There you go. That's an example of visualization for seismic interp, some of the new features that we have introduced. Now with seismic well tie, like I mentioned, we can extract different wavelets. Here I'm just showing a statistical wavelet. We have different window functions if we want to smooth the wavelet, and we can change the phase. It's not an issue. We can swap to an analytical approach if we wish, change the center frequency for a Ricker wavelet, change the length, etc. And then finally, oops, what happened here? I don't know what I did. Okay. Here we go again. I'm sorry, I clicked a wrong button in my mouse. So I was extracting a statistical wavelet, and I'm just changing some parameters. These get updated on the fly. It's very, very robust. We have tested this with real projects, real clients, and it's very efficient and quick. There you go. Here's my Ricker wavelet. And then when I'm happy with my wavelet, I can convolve it with my reflectivity series. And this is a seismic well tie template that is embedded in tNavigator. There's no need to create this from scratch. Everything is there for you. It's very, very, very quick and efficient. And then here on the right-hand side, I'm just showing the seismic well tie module. I'm just highlighting here, I post the video. We have good housekeeping and data management tools to make it easier and have a more organized project. Here we can say, okay, please just put all the objects from my well tie into a new folder, and we can name that. So it's so easy to have everything organized. There we go. So we can have TDRs, synthetics, etc. And this is one of the key new features of the well tie module. We have implemented a dynamic time wrapping approach to calculate the best kind of shift or the best alignment between the synthetics and the seismic data. It's very, very robust. We can have a quantitative kind of approach and have the best and calculate the best adjustments. I'm sorry, for the well ties. We have tested this again with several clients, and they love this feature because it's interactive and we can do and undo any of these. And we have obviously the classic stretch and squeeze or just bulk shift if needed. But this is a great feature to have. There you go. I'm just updating the cross correlation calculation window, and we can see that we can restart if we want. We can also do the classic stretch and squeeze if we want, adjust the TDRs, set some anchors, and then once we have a TDR that we're happy with, you can just apply it and take a look at that at the interpretation window on the right-hand side. This is an older version, by the way. I'm doing kind of the manual way to set the TDR. Now we have a brand new TDR manager where it's just so easy to have updated TDRs on the fly. So that's seismic well tie. I think I really love this tool. I think it's one of my favorite things in tNav just now. Let's move on to another nice layout here. Again, I'm just visualizing some seismic data. So I have my original amplitude data top left, then some RMS attributes, some blended. I just blended some attributes and boosted some colors, some spectral decomp or RGB cube, bottom left, and bottom center reflection intensity, and then some chromatic shift on the top right. So you see that also everything is synchronized. It's not, this video is not edited. Everything I move at time slice is gonna be updated for all the different versions. I don't need to kind of do it manually, so it's very easy to visualize all the attributes in one go. There you go. So moving up and down, I just have everything synchronized. And now let's take a look. After we did some attribute analysis, we can start extracting geobodies directly from the seismic data. There's no need anymore to sample this into a grid and then extract the geobody. It's done directly from the seismic data, which is very, very efficient. So here I'm just extracting the channel, a geobody channel. But now the real power of tNav is that once I extracted that channel, that geobody, there you go, I sampled that into a 3D grid, geocellular grid, and I can populate now that channel with different codes or fasces. There you go. Here we have on the top left, we have the mudstone, sand, and silt, and this is now in my grid. It's not in seismic. It's not an independent geobody that needs to be a little exported as points and then loaded into another platform. No, it's in tNav. I extract it from my seismic, and then I just send the geobody to my grid, and now I can do my property modeling. I can do whatever is needed. I can just send this to my colleague, and we can start doing some static modeling, then dynamic modeling, and obviously we can have. There you go. And you can see I'm zooming in, so you can see that these are actually grid, a 3D grid, and then we can do a proper uncertainty analysis. Now, let's take a look at this feature. This is a spectral decomp. We do have a dedicated spectral decomposition tool in tNavigator. And here again, I'm just gonna pause this for a moment. I just set up a very classic looking layout. I have a 3D window at the top, bottom left, seismic tab or interpretation window. On the right-hand side, I have my amplitudes and an envelope at the bottom. As you can see, this is not edited. As soon as I move my time slice in my 3D, it also moves in the 2D maps that I had. And this dataset is very good to see some channels. I can see them directly from the amplitude cube, PSTM, but also in the envelope. I can start investigating those channels. There you go. So there's some mega channels there in this data set. They're so clear. So maybe let's take a look at the frequency content of those. So we can do that in tNav. We can just here, I'm just gonna pause here in a moment. Once I take the frequencies, there you go. So we can analyze the frequencies in tNavigator with different tools. In here, I'm just taking a window in a seismic tab on a cross line. However, we can also extract the amplitudes for a 3D cube if we wish, or per trace, and set the number of traces. So it's very, very easy. And you saw here, just saw that mega channel, and I drew a rectangle around, and I got my frequency content, and I can see that we have very clear dominant frequencies. So I can input those now. There you go. I'm just doing a very quick frequency analysis from the seismic, checking the frequency, dominant frequencies. Once I'm happy with that, there you go. I'm just opening the calculations, which is the most important bit in tNav. I go into my spectral decomposition calculation window. There you go. I'm just gonna pause that in one moment. So we have although it looks like a normal or like any other attribute, is a calculation on its own. It's very, very, very powerful. So we just input the amplitude cube, select an output. We select the decomposition algorithm. We have 8 of them. Here I'm just choosing envelope, which shows a wavelet type. Here I'm just choosing Ormsby. And then when we click the Analyze Input Seismic, here on the left-hand side, we have the frequency content of the cube in gray, and then we have the independent channels that we'll be using to filter the data. So RGB in there, and it's interactive. Once I change the bandwidth for the different channels, you can see that those get updated here on the fly. So it's very easy to see which frequencies will be contributing to the kind of the final RGB cube. Once I'm happy with that, I can also adjust the linear gate per channel if we want. But once we're happy with that, we just click apply, and we will have an RGB cube. There you go. So I have an RGB cube. I'm just going to move those lines out of the way. And you can see that the results are pretty good. There you go. I put my color palette, and in 2 seconds we have a very good result. We have super clear channels. There you go. And I can scroll and start taking a look at those in my 3D window or my 2D maps. It doesn't matter. And it's all interactive and connected. Then I can move this a little bit forward. I can maximize my visualization space. And what I'm doing here, I'm just gonna go and say, okay, I'm gonna insert a stratigraphic slice. This is it's not a new feature, but it has been reworked in the newest version. So I'm just gonna pause, oops, my bad. There you go. Yeah, I'm gonna pause this for a moment. So a stratigraphic slice is very, very useful to do some stratal slicing. We can slice, we can choose between 2 slice modes. We can select parallel or proportional between 1 or 2 horizons. We can use seismic horizons. We can use horizons. It doesn't matter. And it's gonna be very, very powerful to kind of highlight or visualize features that are not visible in a normal 2-way time cube. So let's take a look. I'm just inputting some horizon that I interpreted. I'm selecting parallel, single horizon here. I'm just selecting some parameters. I'm just gonna do a parallel slicing for this stratigraphic slice. And we'll see that it's so quick. We just select an offset in milliseconds, and there you go. I can just start to do the slicing, and we'll see in a moment that some of the features will be more visible than in the normal 2-way time cube. And there you go. Now we have less noise. We have a clearer version of the structure of these channels, and it's so easy to work with, and it's very interactive. There's no need to be closing and opening menus. We can do this on the fly. We could have two horizons as well, conformable horizons, and do some proportional slicing, which could be even better. But here I'm just doing a very quick parallel slicing, and at some point I'm gonna find a channel that was invisible in the normal 2-way time cube. There you go. Oops, there you go. So top right here on where my mouse is, we can see this blue channel, which was totally invisible in the normal kind of 2-way time RGB cube. Yeah, there you go. Very nice channel, and it took me, I don't know, less than 5 minutes to do all this analysis in tNav. So this is spectral decomp. Now, to conclude, I just wanted to share with you some key takeaways. So the seismic module is full. We cover the core geophysics workflow from interpretation, well tie, attributes, and velocity modeling. Something that is very, very important to mention is that the seismic module contains everything. There's not sub-modules or sub-licenses for anything. So everything is included in the seismic module. So it's very, yeah, it's ready to do your full workflow without the need of having any other kind of plugins or additional licenses. The most important bit is true integration across all disciplines. We developed the software very, very quick. And we have proven workflows that cover from seismic to simulation. We really close the loop from seismic to simulation within one platform, one source code. And there you go. What are the next steps? Just get in touch if you want to try tNav. We're more than happy to help. And just to finish, a nice AI image for every one of people working in tNav, collaborating within one platform. So that's me. If there's any questions, please write them in the chat, and we'll be happy to check them. Thank you.
Thank you so much, Elias, for a great presentation. I hope you all enjoyed, and thank you for attending. You will receive a follow-up email that contains a short survey, and we would be grateful if you could take a minute to complete that. Moving on, there has been a few questions, so I will just read them out, and if you could answer them for me, please, Elias. So the first one is, can you work with non-digital data such as TIFF images and digitize onto these?
The answer is yes. We can geo-reference JPEGs or GeoTIFFs we can do that for either very, very old 2D seismic lines. We can georeference them and visualize them at the right place. And then we can maybe start working with them with some point data. It's not an issue. We can also digitize kind of satellite images and digitize kind of contours if needed, and have quantitative values attached to those. So the answer is yes. It's very easy to do.
Thank you, Ellis. The next question is the seismic module coming with geomodeling part, or is it a separate module to purchase?
Thanks for the question. So seismic module, it's a module on its own. We do have the geology designer module, which is for the kind of the static modeling approach that covers the geological workflow. So that's a separate module, geology designer.
Thank you, Ellis. The next question is, are there any plans to develop a rock physics module?
Thanks, Robin. So we've been getting this question a lot. The answer is yes. We are starting to check with the developers and the product team what's the best way to tackle this. But yeah, it's in the pipeline.
Okay, thank you. There's just a couple more questions to run through. Someone has asked, how about OSDU?
That's a great question. So we're fully compatible with OSDU. It's integrated in the kind of the calculation that you can, at least for seismic data, there's an option to say, okay, load my seismic from OSDU, and there's two options. You can either download seismic data from OSDU and have it on your computer, the cloud, local cloud, whatever, or you can stream it directly from an OSDU instance. So yes, fully compatible and native to tNav.
Okay, thanks, Ellis. And just one last question to wrap it up. What is the experience like of taking seismic interpretations to static model?
Thanks. So it's very easy. It's one platform. So basically all the objects, all the interpretation products that we create within tNav, faults or horizons, they can be just sent directly to the geological model. And the most important bit is that it's at some point an interpretation changes, we can have everything streamlined in a workflow. So if for a reason we change an interpretation and we already have a static model built with that interpretation, we can just rerun, click one button, rerun the workflow, and everything gets updated on the fly. No need to rebuild from scratch anything. Everything is streamlined and automated.
Great, thanks so much, Ellis. If I could just get you to move on to the last slide, please. Thank you. Yes, so thanks again to everyone that's attended the webinar. I hope you found it beneficial. We do have our final webinar of the series this Thursday, which is Plume Dynamics, the influence of geological heterogeneity, solubility, and grid resolution on CO2 storage efficiency and trapping, and that will be presented by my colleague Serkan. The sign-up link can be found on the same website, and again, that's on Thursday at 10 AM UK time. But yeah, thanks again. If there are any other questions, the team will follow up with you just individually. We will see you hopefully on the next webinar.